Okay, great.
Yeah, thank you so much. So today we'll be looking at functions and how to use them and using conditions, so for loops and all those sort of things, right? So so this is for yesterday. So I'm gonna open a new file. So I hope you guys remember how to open a file, right? So we go to file, new file, and then an R script. So I'll save that one as day 4. I mean, you can work on the old script, so it doesn't really matter, but I just want to keep track of what I did for each the different days. And then I save that. So I have a new clean file, right? So just for you to probably you can ask yourself about like, what is the importance of having to create functions? So today we'll be mostly looking at functions, right? So personally for me, the importance of functions is to avoid having to do the same operation over and over again, especially if large data set. Like in my research, I deal with a lot of data set, and I don't want to keep doing the same thing over and over again for the same data sets, right? So if I have a function, then I can just put the parameters that I want, and the function does everything for me in a short period of time, compared if I were to do the analysis over and over again for the different files, right? So for the purpose of illustrating functions for now, before we go, so we're going to be doing the analysis on the very same data set that we looked at yesterday. And for now, I'm just going to try to introduce a simple function, and then we're going to build on that, on how we can use functions to analyze multiple data sets, right? So for the purpose of this, try to think of a function that can convert one temperature to another, right? So in mostly, I know in sciences, we mostly deal with Fahrenheit, with Celsius, and also with Kelvin. So for now, we are going to look at those functions, right? So So for now, we're going to try to convert from Fahrenheit to Celsius. So the conversion for that, so let's see be temperature in Celsius, and then let F be temperature in Fahrenheit. So C will be for Celsius, and then F will be for Fahrenheit. So wherever you see C, I mean Celsius, right? And this equation that makes us to move from one temperature to another is given by this way. C is equals to Fahrenheit minus 32. That should be in brackets, right? And then we multiply that by this ratio. So this is just the conversion from degrees Celsius to degrees Fahrenheit, right? So now what we want to do, let's say we have this large data set that's given in Fahrenheit, right? So that's given to Fahrenheit, either Fahrenheit or Celsius, and we want to convert one temperature to another. It's going to be tiresome, like having to do this with the temperature, make an equal sign, and everything is going to be tiresome. So rather, we are going to make a function, right? That will take any Fahrenheit value and then give us a Celsius value, right? So let's call that function Fahrenheit to Celsius, and you can call it whatever that you want. To Celsius, right? And since I'm defining a function, then I need to use this convention function. And if you hover over it, it's going to tell you what it does. So you have a function and then the function parameters, right? Then I'm just going to click on it like that. So this is the name of my function, Fahrenheit to Celsius. This is the name of my function, right? So now what I have to input here is of a variable that when I input my value in it, then it gives me the temperature in Celsius, right? So here, whatever that I'm gonna be putting here will be my temperature in Fahrenheit, right? And once I run this function, it's gonna give me the temperature in degrees Celsius, right? Let me send that again. Yeah, I think this is fine. Is this visible enough so far? Or should I zoom in more? Is this fine or should I zoom in?
No, that's good.
Okay, great, thanks. Yeah. So now this is the name of my function, and I'm telling this function to take in a value in Fahrenheit, and it should return to me a value in Celsius. So this is just an argument of my function. And for me to proceed to define this function further, I need parentheses. So I need this, right? So now everything under this will be the conditions and the equations that I'm going to be using to tell this function what to do, right? So I'm telling this function that if I have my temperature in Celsius, right? So basically, it's just going to be this equation. So what I'm writing in line 6 here is basically equation that I have in line 3. So the temperature equation, so that would be where F is temperature in Fahrenheit. And I think it would be useful for you if you can kind of like code along with me, because from here onwards, it's going to be very hectic. It's going to be hard for you to keep up if you don't really code with me. Yeah. So I'd advise you that actually code with me. And if you are stuck somewhere, then we can look at it together so that you can be able to follow easily. Then we have temperature in Fahrenheit and then minus 32. Don't forget your brackets. It's kind of writing the whole equation, then 5/9. So this is what I have so far, right? But now the function needs to return this value in Celsius, right? So I have to tell it what to do. So it needs to return. And then if you hover around it, it tells you what it explains what it does. So I needed to return the temperature in Celsius. So if I don't put the return statement, then it's not gonna give me the temperature in Celsius, because I'm not telling it what to do. I just defined the function and I only included the equation. So without this, the function is not gonna do anything. So if I say return the temperature in Celsius, then whenever I have an input in Fahrenheit, it's gonna give me an output in degrees Celsius, right? That's fine, I can run that. And now, if I want to use my function, I take the name of my function, right there, don't forget your brackets, and I put any value that I want. So whatever value that I'm gonna put here is actually in Fahrenheit. And whatever value that I'm gonna get after that, it's gonna be in degrees Celsius. So I run everything. And then my value in degrees Celsius, let me make the console a bit up. My value in degrees Celsius is minus 15 degrees, right? So I have my value in Fahrenheit, and then it returns me my value in degrees Celsius. And we can do the same thing with the other temperatures. We can do the same thing with Celsius to Kelvin, Kelvin to Fahrenheit, and stuff like that. So now let's try to do the same thing with Kelvin, right? So the equation from Kelvin from Celsius to Kelvin. So the equation for that, what we have, so let me write here. So this is Kelvin and Celsius equation. And where Kelvin is going to be represented by by capital letter K. So whenever you see K in my equation, just know that that is Kelvin. Right, and I'm going to do the same thing, a similar thing actually. So now I'm gonna convert Celsius to Kelvin, right? So here I'm gonna have Celsius to Kelvin. So whatever value that I have that I got here in line 7 for the temperature in Celsius, I wanted that whenever I get it, I want it to be converted to Kelvin. And then I'm also gonna write these two codes to be one single code, to be a compact code. And then we're gonna see that later on. So now we have Celsius to Kelvin, and then the temperature, the input should be in Celsius. Because I'm gonna take the temperature in Celsius and then convert that to Kelvin, right? So this should be a temperature in Kelvin. And what is the equation that relates Kelvin to Celsius? If anyone can look it up quickly.
Excuse me, ma'am.
Yes.
Mine doesn't want to work at line 6. The store, the store and the bracket, it says something is wrong.
Can you please share a screen so that I can see exactly what you are referring to? Are you able to share a screen? Yeah. Or let me stop mine. Let me stop sharing. Okay, I see a screen. Could not find function Fahrenheit to Celsius. Oh, I think did you run line 5 beforehand?
No.
Yes, you have to run that first because it's complaining that it doesn't know this function, but already defined it. So you can.
But also, it looks like maybe there's a bracket missing because, like, there's a temp F.
Yeah. There's a bracket there on the left before temp F underscore F. Thank you so much, Amy. Yeah, right there. Yeah, that red cross should be gone now. Yeah. Thank you. Yeah, please stop me if I'm moving too fast. Or just pause me if you think I'm moving too fast.
Okay,
So
thank you.
Pleasure. Okay, I'll share my screen again. Desktop. Yeah. So I was here. So now we need to convert from Celsius to Kelvin, right? And if you get the equation, you can just look that up. If you get the equation, it's gonna be the temperature in Celsius, right? Plus 273.16. So that is the relationship between the temperature in Kelvin and the temperature in degrees Celsius, and it's going to return the temperature in Kelvin, right? So if I call my function and tell it to convert a certain temperature from Celsius to Kelvin, let's say 100. Gonna file function. I did not run this function first, so let me select everything and then control, enter, and then now here I have my temperature in Kelvin 373.16, right? So as I told you that you can actually write this in a more compact way instead of just writing it like different lines like that. You can just compose the functions. So this is what we call composing functions in root, right? We can actually do it the long way or we can do it the short way, but I'll show both ways and try to see which one you best understand, and you can try to use that in your own work. So now we are going to be trying to compose functions. Compose functions. And if you want to look up something that I wrote before, you can just let me know, since I'm just scrolling down now. But if you want to look something up there, you can just let me know. So now we are going to compose functions, right? And basically we're gonna be moving from Fahrenheit to Kelvin. So what we have here and what we have here. So we want whatever temperature that we input in Fahrenheit to give us a temperature, final temperature in Kelvin, right? We don't really care about the temperature in degrees Celsius, even though that is gonna be part of the step, like in between, right? So we can still do the same thing. Define this, the function from Fahrenheit to Celsius, right? But instead now we're gonna say from Fahrenheit to Kelvin. So now I'm in line 26, Fahrenheit to Kelvin. So this is the long way. Let me write it down. This is the long way. And then I'll also show you the short way. So remember, when you're defining a function, start with the command function. Right? And whatever that is going to be in the brackets here are going to be your arguments, right? So we are telling this function to take in the temperature in Fahrenheit. And then from there, we are telling it to return it to give us a value, the temperature in Kelvin. And we want the temperature in Kelvin, right? So this is the final thing that we want. But we still have some missing steps in between. We need to know how we can convert Fahrenheit to Kelvin, but we also said that since we're going to do the long way, we're going to convert from Fahrenheit to Celsius and then from Celsius to Kelvin, right? So the temperature in Celsius, we had it here. Is this equation, just copy from line 6. And then I just pasted in line 27 there. So that is the temperature in Celsius, right? So from Fahrenheit to Celsius is given by this equation, right? And then from there, we are gonna take the temperature in Kelvin, which is line 16, share, and then it's gonna help us return the temperature in Kelvin, right? However, this and that are gonna change after this arrow sign. The temperature in Celsius and the temperature in Fahrenheit. So basically this equations, the right side of this equations actually gonna change. So the reason why that's gonna be, so we're saying the temperature in Celsius is gonna be Fahrenheit to Celsius. And then the input, remember for that, was the temperature in Fahrenheit. And then I'll explain this more after we've done writing the code. And then here we have Celsius to Kelvin. Then the input here would be the temperature in Celsius. Right, so this should return the temperature in Kelvin, right? So let's go back to what this function does, right? So we've named a function that converts temperature in Fahrenheit to Kelvin. But since this is the long way, we also included the conversion from Fahrenheit to Celsius and from Celsius to Kelvin, right? So this function takes in an input in Fahrenheit, right? And then gives us the temperature in Kelvin, right? But then we start with it. So after getting the input in Fahrenheit, it gets converted in this line, in line 27, it gets converted to the temperature in Celsius. And then that value in Celsius is taken to line number 28, where it gets converted to Kelvin. And then the final result in Kelvin is what we obtain in line 29. So let's see if that works. So we're gonna call our function So it's the name of the function and then the brackets, and the input is the temperature in Fahrenheit. So let's say 20. Then I'm gonna run the whole from line 26 to line 32. Control Enter. So this gives us the temperature in Fahrenheit, in Kelvin, 266.49 here. So this is kind of like the long way of doing it. I mean, the short way is not even that short, but it's just minus one line from here. So I'm hoping everybody is on par with what we have done so far. And if you need me to pause a bit, just let me know and then I'll do that. So let's try to look at a slightly short way. It's not that short, it's just slightly short. Right? And then I'll just copy everything and then make changes as I go along. Right? So now in the short way, we are gonna incorporate the equation that converts the temperature in Kelvin and in Fahrenheit. And you can also just look that up, like the conversion between Fahrenheit and Kelvin are gonna be using the standard equation. So we will not be relying on the conversion from Fahrenheit to Celsius. So Celsius now is not into play. We just want the relationship between Fahrenheit and Kelvin. But if you wanted the relationship with Celsius, you can also have done this part. But for now, we don't need that. Right? So from here, what we need a function that converts Fahrenheit to Kelvin. And if you look that up, you can find, so the temp in Kelvin is given by 5/9, and you multiply that by the temp in Fahrenheit, and you minus 32. Then plus 273.15. So this is the standard term relationship between Fahrenheit and Kelvin. So instead of this having to convert from Fahrenheit to Celsius to Kelvin, you can just use the relationship between Kelvin and Fahrenheit and use it like this. Let me say this is Kelvin 2 so that we can do a comparison between the two numbers. Should be the same. If it's not, then we did something wrong. Yeah, it's the same. Let me make this a bit up. Yeah. So it's the same. We have 266 and then we have 266. So it's the same. So you can use the long way or just directly the relationship between Fahrenheit and Kelvin. I'm hoping everybody can follow so far how we can actually use functions to do stuff for us. So basically you can just call the function wherever it is, even if you're at some point down in your editor and you want to use the function, you can just call it and then use it however that you want to, and then we'll see how that is very useful later on. Right? So actually we want you to try to write a function. You can name it whatever that takes in two vectors. Probably might not be able to do this now, but you can try to do, I don't know, something about it. That takes two vectors as arguments. So remember here we only have one argument, right? So you can make it to take multiple arguments depending on what your function wants. So try to make a function that takes in two arguments and returns a new vector or a new function with those arguments. So a function that takes in two arguments and then returns a vector containing those two arguments. All right. So, write a function takes in two arguments. It could be anything. Let's say it's X and Y, the arguments that you're looking at, it's X and Y, right? Let me move this to a new line. So this is not so limiting because it could be anything. You can also have numbers in there. Which returns so what the vector should return, it should include the both arguments that have been included. So you can try to think about that. So this is not so limiting. You can be as versatile as you want to be, right? So try to do that probably during the break. Okay, so let's continue. So now let's assume you want to make a function that takes in more input values. So I probably can do this after during the break. So you want to write a function that takes more input values. So you can take more than two. You can take how many input values that you actually want, right? And let's say I call it my sum. And I say function. So I can take as many input values as I want. So for now, I'll just say input 1 and input 2. Then don't forget your parentheses or brackets. Then it should return something, right? And then whatever execution that I'm gonna be putting here, it's gonna tell you the relationship between the inputs that you have. Can be like an equation, right? So let's say my output, right? So this would be my output. So what I want to return when I have my two inputs there is my output like that. And this would show you the relationship between my inputs. So let's say I just want to make a summation of whatever values that I have. Right? So this function will take these two inputs and then sum them, then give me the result. So if I call my function, and the way I can actually use this function, I need two inputs, right? So I'll have 1 and 2. Let me run this, and then I get 3.
I don't know.
Is someone saying something?
Sorry,
Oh,
I
okay.
was still I was still not mute.
You're still not?
My sound was on and I forgot to mute. Sorry.
Okay, no, it's cool. Right. So this function just sums these numbers for me. And whenever I need it, I can just call it. So I can include more inputs and then do the same thing. And then make include a relationship between those different inputs and then return the output that I want. Then when I use my function, I can just call it and then include the parameters that I actually want the function to deal with, right? So now, as you can see here, I can change my inputs. So what about now if I want one of the inputs to actually be constant? So we can make another function, or let me just use the same one. So I need one of those inputs to be a constant throughout the whole analysis. Let's say you have some big data and you want to make one of the inputs to be a constant. So let's say I want to make input 2 to be constant, and I will change it if I need to change it. So I make input 2 to be constant. And then I run this. It still gives me 3. Why is that? Why do you think that's the case? You can send your answers in the chat. Because I'm telling you that for my input, it should be 10. But my when I call this function and then I sum 1 plus 2, it still gives me 3. But I told it that for my input, it should be 10. Why do you think that's the case? Do you have an idea why it does that?
I think you should put the change somewhere inside the parentheses. Parentheses.
Oh, no, yeah, I
Parentheses.
get you. Yeah, I get you. So what it actually does is that when I put a different input for number 2, it overrides what I have here. So that is what it does. Yeah. So that is still fine. But if I wanted it to just, so if I didn't specify input number 2 is gonna put the standard one, which I've predefined in my function before. So if I specify a different one, so I'm telling, I'm commanding it to override the initial one that I've actually put. But if I don't change it, then it's just gonna use the old one. Because now when I didn't put the 2 there, my output now is 11, which makes sense because 10 plus 1 is 11. So it didn't override this one. So that's one of the things that it can actually do with functions. You can create a function where one of the inputs is constant, and if you want to override it or change it, you can also have the flexibility to do that, right? So that's essentially it, especially with functions. So now let's see what happens if, so now I only did my sum 1 and then I didn't input anything there. So let's see if I do this. Right. And then I just put the 1 without any comma. It still gives me the same thing because it's assuming that whatever that I have here, it's my input 1. And it's gonna sum that with the constant input 2, right? So now if I do this, if I say input 2, let's say 2, it gives me an error that input 1 is missing. But we saw that if I put input 1, it doesn't give me an error, right? Because if I just put input 1 without input 2, it's automatically gonna use the input 2 value as being 10. But for the case of line 51, if I just include input 2 only, it doesn't know what input 1 is, so it gets confused. So, and if I predefined it here, it was gonna be fine. Let's say input 1 is 2. And then I run line 51 again, shouldn't give me an error. This is fine, because already it knows that input 1 is predefined in line 45. Right? So those are one of the things that you can actually do with functions. You can predefine your values if you need to. And then if you want to change them, you also have the freedom to do that. So are there any questions so far? I'm hoping everybody can follow along. No questions, okay, we can continue then. Let me put this down. let me work on the same file, like on the same function again. Listen now, same function, but now I have multiple inputs. Then I have another input 3, right? I don't have to define it, it's fine. Then I multiply that with input 3. The name doesn't matter, you can name your functions whatever that you want. Then I have the output. Don't forget to run this, right? So if you run line number 50, just say my sum 1, comma, without any other specifications, what do you get, or what do you expect to get? So now I've included input number 3, and we're just running line number 50. What do you expect to get? Or what do you get when you actually run it yourself?
I didn't run it, but I think so input 3 is not mandatory, maybe.
Pardon?
Input 3 is not mandatory, so I think it will go through.
Okay, this will go through. And then what do others think? Will it run? If it runs, what value do you think it's gonna give us? Okay, so try to type the code in your console. I'll give you like 3 minutes and see what you get when you run line number 50. So quickly type this in your console and then see what you get when you run this.
It worked for me.
Rex number 50. And anyone else? Is anyone else getting a different thing? Let me run this again. It didn't run it the first time. With input number 3. How did it work after running line number 50? It shouldn't work. Because I have input number 3. But when I was calling my function to do the sum, I didn't specify the value for input number 3. So it shouldn't work. How did yours work then?
Can
I
you see
think
my
you're
screen?
speaking. Let me stop sharing mine. Yes, I can see us now.
Yeah, so I made different function, so I make it multiply.
Yeah, okay, that's fine.
Yeah, so I created those 3, and the same result shown here. I think multiply 2, 3, and made empty. The third one
Oh,
is missing,
yeah,
and it gave me
but
the same answer.
your output in line 23 doesn't include Z, the third parameter.
In line 23, line
Yes,
28, you mean?
23. No, 23. So it
Um,
doesn't complain because it doesn't know Z. It didn't use Z.
mm, but I added it in the function. So now there is no point of adding it. something in the function, but it's not in the output. Am I correct?
No, it's in your arguments, right? You're telling it that the function is x, y, z, but
Mhm.
there's no relationship between x, y, z. There's only the relationship between x and y.
Mm.
Yes. So you don't include z in any way. You only include x and y.
But here, why they mention that error and multiply? I can make it smaller. Yeah, with no default.
Now the screen is a bit small. Can you please increase it a bit?
No, I want to make it because I can't see the end of the screen. The zoom.
Oh, okay.
yeah.
Okay, no, it's fine.
Argument
So
y is
that
missing.
with no default, that is for line, which line is it?
I think
Oh, that is for line 29. Yeah, it's for line 29. It's complaining because they're saying x multiplied by y. It knows
yeah.
x is 2, but it doesn't know what y is.
Yeah.
Yes,
You
so
want to
that's why it's
select, yeah.
complaining. Yeah.
So here x, y, and z. If I make it those two, then multiply this with z. I think you are better than me in math. Right. This is correct.
That's why I didn't need the brackets, but it's fine. So
But how? Which one to start with? X multiplied by y multiplied by z?
the order doesn't matter in this case. We are all multiplying. It doesn't matter. We don't have different operations, just multiplication. So run number 26. Okay, after this, and run number 26 and should now that's fine. Yeah. Because now it's complaining that there's no z, yeah, and z has no default value. Yeah.
Okay, good. Thank you so much.
Pleasure. Let me go back to sharing my screen. Okay, great. The same thing with 51 is going to give me an error because input 3 doesn't have a default value. But if I put something, then it's going to give me an answer, right? So generally, you can do this for almost all things that you want that must be in a function form, right? So let's try different things. So now let's try to write a function. You can call it whatever that returns a vector made up of just the first and last elements of its input. Right. So a function made up that returns a vector made up of its last inputs. Let me write this in a second line. Right. So now let's try to write a function that returns a vector made up of the first and last elements of its input. The first thing that we can just do to name it so I can use new, let me say elements. That'll be the name of my function. So this is the first thing that we can do whenever you write a function, and then you'll figure everything out later. Then you know it's supposed to return something, right? So what we want is a function that returns a vector, right? Made up of its first and last elements of its input, right? So let's say we have some input here. We can have multiple inputs, that's fine, but for now, let's just deal with one, right? We have some input, and we need a relationship between the input and the output. So this is the output. And we need a relationship. Like, how do they relate, right? So yesterday, remember, we used this command where we can actually make a list of columns using this, right? And then we can make a list like that. Let's say I say A, B, C, D. And we also have to include quotation marks there. Right, so we can also do the same thing, right, using the very same convention and do the same thing. So I'm gonna say C. We don't know the relationship so far between the input and the output, right? But what we know is that for the output, whatever answer that we get, it should include the first and last elements of the output of the input. So we'll just say input. And since we want the first element, remember when we dealt with data for the first entry, you can just make the square brackets and say 1. That should give you the first entry, right? Same thing with here. If I want to get A, let's say I name this, which is 10. I name this into Zen, right? Then if I want the first input of Zen, then I'm gonna say Zen, and then 1. I'm gonna run this, then it gives me A, right? And if I want the last output, I would say 1, 2, 3, 4. So there are 4 entries, and the last one is the 4th one. I'm gonna say Zen 4, right? So now let's assume that Zen is very, very long. It's very, very, very long, and we don't know how long it is, but we just want the last output. So in order for you to do that, you can include the length command. So if you write, it can tell you what it does. It gives you the length of the object. Of course, the length is determined by the last entry of that object, right? So if I try to determine the length of Zen, it gives me 4. So it means that the last entry here is number 4, right? So you can still do the same thing in this function. We're gonna take in the first input given by input and then square brackets 1. And then in order to get the last output, we are gonna use the length command, right? So we're gonna say the length, and it's gonna be the length of what? The length of the input. So that should give us the last output, once the last elements of the input. Yeah, that should give us the last element of the input. So this is how you write it. There's an error. Oh, I need another bracket there. And this should be fine. The length of an input. I think I added something extra here. Just need to figure out what. I need another bracket. I'm not sure. Can you please assist, what's the error? Because it says unexpected. Look, oh yeah, this should be in the same thing. So this length, and so there's gonna be input number 1, right, and then comma, and then after that there's gonna be input and then this, and then that. I think that should be fine. And additional bracket there. If something is wrong, now it's fine. Yeah, I had the additional bracket there, which I didn't need because the closing bracket is here, not there. So what this function does, I needed to return a vector made up of its first and last elements. So if this function, it takes in some input, we don't know what the input is, but we know that it takes in some input, and it's gonna return the first input. For the output, it's gonna return the first input and the last of the elements of its input, the last element, by using the length command as I've shown here. The length command, the last input is input number 4. So this is how we can actually use functions. Are there any questions so far? Should I return to some particular line? Are you guys okay? Any questions? I'm guessing everybody's following. Okay, that's good. So don't forget to save your file so you don't lose everything that you've done. If this doesn't, it's fine. Yeah. So from here, we'll be using the whole function, like functions, to analyze multiple data sets that we had yesterday. Remember yesterday, we only analyzed the first file, inflation 01. So now we're gonna also try to analyze multiple data files. Community and research have all these multiple data sets and you want to analyze them. So we're gonna try to do that. Right? So let's get to that before. So we are still going back to what we did yesterday. So let's bit of a recap on that. Yeah. Should I start with it already, or should we take a break now and come back a bit early because I see it's almost 10? What do you guys think?
We can
I think
take
it
a break.
makes sense. Yeah, I think it makes sense to take a quick break.
Okay, that's fine. We'll come back at 10 then. Let me stop sharing. Yeah. I'll try to share my screen, then we'll recap what we did from yesterday so that we all remember, because we are gonna working from there. So share my screen. Oh, sorry, yeah, before I share my screen, Andy, can you please share screen first so that we can try to sort out your issue?
Oh, this one now?
Pardon? Yeah, okay.
Yes, it
Yes,
doesn't want to calculate anything. And it shows this green button.
I tried to run something. That I'm just gonna show you that because you haven't really used the function. Try to run line number 58. It's telling you that you should add more. Why is that? Go to number 57, run number 57 first. So it has not been running all the time.
No.
Okay, that's weird. Please scroll up on your console, sorry. Why does it give you the pluses? Is that how you set it up? Because I've never seen such before. Let me.
I don't know. It worked yesterday, but somehow today it just is basically copy and paste.
Yeah,
Doesn't
that's
work out.
funny. Let me try to see if my console shows that too. It should be fine. Try to save your file and run it again. Just control save.
What should I run again?
Yeah, it's fine. You can just run 57 and 58. Because with the plus sign is telling you that you need to add more commands. Has anyone ever experienced something like this? Because I haven't seen something like this before. So my bit start out with it.
I just Googled it and they suggest like try in the console, like if you click in the console, just try pushing escape. Like when you're, just click somewhere in the console and then try like escape
Okay,
on the
try
keyboard.
that.
Did that
Okay,
work?
now, yeah, that should, yeah, this is fine then. I'm supposed to see that
Ah,
everywhere.
thank you.
Oh, thank you so much,
Okay.
Amy. Yeah, I've never seen such thing like this before.
Yeah, it's the power of Google.
I know. That's great. Yeah, I hope everybody's on track now. Yeah, I feel like that's one advice that I was given by one of my lecturers when I started like the whole computing thing and coding, was that you won't really know everything, and one thing that you can do is to Google and find answers there. So that is one of the tools that I actually use, like a Google, try to find something. And I also make comments as I write my course, because sometimes you forget, I haven't seen this before. So this is something new for me. So yeah, so let Google be your friend. That is what Amy has taught us today. Let Google be your friend when it comes to coding. So let me share my screen. And yeah. So just to recap on, because I just gonna build on what we did yesterday. Just a recap, we read our file, loaded our data file, determined the classes, and one of the most important things is that we did statistics on it. So we're able to determine the mean, the maximum, and the minimum, and the standard deviation, right, for the average day information and all the others. And we were able to plot the average day inflammation, right, and the max day inflammation. So this is done over the columns by using the apply function, right? So now when you come to day 3, only did that for one data set. So for only just this one data set, yeah, inflammation 01 CSV. And remember that we have multiple of those. So if you go inside of data, and then you can see that you have a lot. So it's from 1 until 12, the inflammation one, so excluding the other ones. For inflammation, it's just a data file 1 until 12. So we didn't look at everything, only just look at the first one. So today, that's what I'm gonna try to do. Gonna try what we've already used so far regarding functions, and try to do the same thing for all the other data sets without having to write individual codes for each and every data set. Right. So we only did the mean, we only plotted the mean yesterday. So let's try to plot other statistical measure like the next day. So on day 3, we did the average, which is the mean, right? So this is what we've done yesterday. So I'm gonna also use that a bit today. So we've done the average day inflammation by using the by using the apply function on our data, right? So let's do the same thing but finding the maximum. So instead of the average, so using the maximum, and we don't have to rewrite this, you can just copy it and then paste it there. So instead of the mean now, what we want is the maximum. Right? And then after that, we are gonna plot that. Right, so we want the mean over the columns and not over the rows. So the average day, so remember that the days were in columns and not the rows. So it means that the margin has to be 2 and the margin has to be 2 again. So let me make this so that you can see where the row stuff actually starts. Yeah. So we have the mean and then we have the max. And then let's plot them. Just say plot, just gonna plot the average day inflammation. And then we have to plot them. Then you can also plot the next day inflammation. So this is the next. Control enter. Then yeah, you can see it's the next day inflammation. Right, so we have other suit. Right, so you can do the same thing with the standard deviation and the mean. And also note that nowhere in this file that I have that, right, that I have the data that I'm working with, right? Nowhere in the file that I have the data that I'm working with. But since I'm still in the same working directory, so this is where I am. I'm still in the same working directory. It kind of like creates what we already defined in the script, like the stat that we already used. It kind of reset. But if you are in a different working directory, then you're gonna have to redefine it. So if it gives you an error saying that there's no such file name called that, just know that you're in a different working directory. It shouldn't give you an error. You're just in a different file, but still can recognize the variable of the data that I used yesterday. So I'm gonna do the same thing with the mean. And just rename it for clarity. And then we are finding the mean for the patients, and then run that. Then I make a plot for it. Do you see how long this takes? Like how tedious this is? Like I'm doing the mean, the average, and the maximum for one data. Just imagine if I had to do for the 12, I wouldn't want to do the same thing. I mean, I would copy and paste, but then that means I would have to change this, right? Because the dead is for the first data type. So it means I'd have to make a variable for the second data, for the third data, all the way to the 12th data. And that's going to be a tedious process. And that is not what I want to do. Let's say now if I have like 100 files, I wouldn't want to do this like 100 times. It's going to take a lot of time. And I'm also prone to making mistakes if I do that, because I'll be editing one bit, and at some point I might be too tired that I might make mistakes. So let me run everything, control enter. Then I have 3 plots, right? So this is the mean day, the latest one that we just plotted. And if you look up there, there's an arrow. the arrows going to the left and going to the right. So if you click an arrow to the left, you have the mixed information, which is the plot I have on line 74. Then if I continue going back, I have the average information, which is the plot that I have on line 73. And if we still continue, these are the previous plots that I made. These are the previous plots that I made. So the latest one is this one, right? So this is what we have. So this is some of the plots that are associated with this file, right? Over the whole columns, over the whole 40 days, right? But that is only just for one data set, as I've explained. So now what we want to do, so the aim is to do the same thing as above to all 12 data files. So we want to do the same thing. We want to produce the plots. I mean, we can also print the values for that. But so far, let's just leave that for now. But you can also print the values by just typing what you have and then control and running it, control enter. So we want to do the same thing for all the other data types, right? So how can we do that? We can use functions for that, right? We can tell a function to read these files, then just make the plots for us instead of having to do the same thing. Right? So we can put that in just one function. So for now, before I include everything for one function, let's do the same thing using a function, but for the same data set. So instead of doing this, let's use a function. So you can name your function anything. So I'll name mine analyze. Right? So this is how you start. I prefer starting like this. I'm naming the function. I don't know what the inputs are. And then I just parentheses. And I know should return something. So this is how I usually name my functions, right? So what I want is for the input, which are the arguments, is I want to have a file name. So despite what the file name is. So I want to analyze a certain file which has a certain name, right? So this is where the tricky part is. So it's gonna get a bit messy from now on. So please stop me. Let me know if you have any questions so far, right? So I have this. It says that 2. But let's just say that is fine. Right? So I'm telling this function that I'm gonna assign a variable called that from some data. And remember that I can't use data because it's an inbuilt thing in root. So that is, I just say that. So sometimes when you type and you want to name something, so if it's an inbuilt thing in root, it's gonna do something different. So also try to make sure that whatever that you name is not an inbuilt package in root. So that is, I just have the that. So I'm saying I have this variable called that, and I want to read some files, specifically CSV files, because that is what I'm dealing with now. I'm dealing with CSV files, right? And these are the arguments for this. So I need to have a file name, I need to have a header and all those other things, right? So file. So far, I can just write the file name of the first one. But because I have this argument, I'm going to use it in this line 18, right? So I'm going to say file name. Remember what we also did yes, you have this argument, right? And then you also have it here. So if you put an argument here, automatically when the function runs, it's going to put that input into the relationship that you've already put there. So the same with this function. I have my argument here, and this is how it relates to this variable, right? So we need to have a relationship. with that. So whenever I change the file name, automatically it's gonna change here in the read.csv command. So I have my file name, right? And I can also include my header. And remember that we put the header as false because in our data, we actually didn't have headers, right? So we're telling this to actually know that we don't have any headers in our data, right? So this is fine. So the file name here is a variable. So whenever I change the file name, automatically this is gonna proceed. So it's gonna replace this, the file name. Here's the file, and then it's gonna read it as our data, right? But now I want to plot the average day inflammation, max day inflammation, and the mean day inflammation for this file. So I also have to include that in my function, right? So let's do that. Let me use small letters. I can just copy this. I don't have to rewrite it. So the mean, the max, and the average. So the mean, the max, and yeah, the mean, the max, and the mean. Right, so I have this. I also want to plot it. So I can have this. And then we have that. So we tell the function after reading that name, determine the average inflammation, determine the max day inflammation, and determine the mean day inflammation, right? So the date here, it's gonna be this, that. So the function won't call the data type outside. So you don't call the data type from here, because remember we made a variable that to this file. So it won't call that. So it is its own thing. So this is what we have so far, right? And already when we say plot, this is what I'm returning. I'm not doing a calculation. So this is what I'm already returning. So it means that I do not need line number 87. Automatically, this is my return. I'm going to be returning the plots. I can run this. It doesn't complain about anything. I didn't miss anything. There's no red cross anywhere. My brackets are fine. Everything is fine, right? So that's fine. And now I also want it to print, let's say, the average day information. So I want it to print everything. And make Control X. Let me make the mean to be together, the max to be together. Yeah, so that to make it a bit neater. So here for this function, didn't do anything fancy. We just copied what we had already that we defined for the first thing that we did yesterday, right? So again, we have this variable data that reads a certain file, and then it determines the average day inflammation and then prints out those values and then plots them, determines the max day inflammation, prints out the values and plots them. Same thing with mean. So this is fine. So let's call the function to analyze the data. Analyze for the first file. So let's do that for the first file, right? So we explicitly have to call it the name of the file. So you can go to files if you don't remember the name. And this is the name. So I'm analyzing inflammation. 01.csv. Don't forget your quotation marks. Yeah. This is how. Right. And it complains that there's no file or no such file or directory. So remember that this file is in a subdirectory, which is in the data subdirectory. So it's in the data subdirectory, and I'm here in the _3. So the file is here. So I have to include the subdirectory. So data _ and then this should be fine. And share this. Let me move this to the side. I have the chats open so that I can see it in everyone. Right? So we have the mean day. So this is what it did for us. So you can go back here. So you have the mean day information, which is line 89. And then if you go back there, you have the max day information, which is line 86. Go back, you have the average day information, which is 83. Right? But you can notice that I wanted it to print the average day information, max day, mean day, but I didn't print it. So let's run this and see what I'm referring to. So if I run 70 and 71, right, it prints the average day information without any other command. It prints it. But now I do the same thing. I'm just saying average day information after this line. It doesn't print it, right? And the reason why is that inside the function, it wants you to explicitly say that you have to print. You have to explicitly say that. So you have to put the print command. So you're printing that. And now you have it. So this is the command that I ran, print average day information, and these are the values. So now I have to do the same thing for the max and the min. You have to explicitly say print. So I'm gonna run the same thing again. From analyze line 80 all the way to line 93. Control enter. So this is where I ran my last command, analyze data information, right? So what I firstly expect is average day information. Here is average day information. It ends here at line at V14. And then I expect it to plot, so the plot is this side. Then I expect it to print again, makes the information, it starts here all the way to 40. And then it prints the max the information. And then after that, I expect it to print the min day information. So it starts here printing the min until then. And then it plots the min day information. Right? So this is fine because I can just put whatever data that I want and then it does everything for me. Right? So imagine now if I was using this one. And remember that this was a variable for the first data. Now, if I want to use the second data, I would have to make a different variable, right? It's for the third data and so on. So this actually takes a bit longer compared to this. Right, so here I can just change the name and it does everything for me. So this is for the second data set. So it was able to analyze it and these are the results. And then we also have the plots that you can browse through like that. Right, but there's also a compact way of actually doing that, right? So here we have 3 plots, which is fine, that is fine. So we can also use like other data points, like as I've shown you here, we can use other files, right? But now you don't want to be busy changing this multiple times. So I showed you the disadvantage of this lines, and I'm also pointing out the disadvantage of this function. It was helpful, it's better than what we did here, but it's still not so convenient because it would require us to constantly change. Imagine again, you have 100 data sets and you have to change this to number 3, run it to number 4, run it. It's gonna take a lot of time, right? So what we can actually use to overcome this, we can use what we call for loops. Has anyone used for loops or know about it? Thumbs up if you did. That I can get an idea of how fast or slow I can be regarding for loops. Have you guys used for loops before? Are you new to it? And Lee, Gisabaka, Prudence, have you guys used for loops before? Oh, this is new. It doesn't necessarily have to be in root, like in any other programming language. If you guys use for loops before, I think that would kind of like give me an idea of how slow or fast I should be with this. Any inputs? Have you guys used for loops before? I mean,
There's
if
some
you even
messages in the chat. I think there's two no's. So I think at least 2 people haven't seen it before.
or they haven't used for loops before.
Okay, there's also a question from Prudence in the Q&A.
Okay.
Sorry, I didn't notice that. Sorry about that, Prudence.
What's the
should
question?
Yeah, should I just read it out? So it's
Yes,
what
please.
does margin equals 2 mean? Is it specific for something? Sorry, this is from like 10 minutes back. Sorry about that.
Oh, sorry. Sorry, okay, sorry. So margin means we are looking over the columns. Right, let me bring back so I use the apply function right here. So you can, if you want to know more, you can just do the apply and then this is what it has. So this is the apply function. You have your input, you have your margin. So margin can only take 2 values, either 1 or 2. And by 1, it means that we are looking over the rows. So whatever that we are applying the function to, we are looking over the rows. And if the margin is 2, then we are looking over the columns, right? So like in this case, the mean the inflammation. So looking at the minimum value of the inflammation over the 40 days. So looking at over the columns. So that is why I have the margin as 2. But if we're looking at the minimum of some value over the rows, then the margin would be 1. So it's basically looking at rows or looking at columns. So that is what it means. Any other questions?
Thank you.
Pleasure. But you said people said they don't really know for loops. Is that what you said from the chat?
Yeah, from the chat it looks like a majority people haven't seen it before.
Oh, okay, that's fine. Then I'll go a bit slow trying to explain it then. So so this is what we have so far, right? So now I'm going to be using for loops. So essentially what for loops does, it allows us to execute the same thing with only a few lines of code, right? So since now I'm saying this is not the most convenient way to analyze my data, right? If I use for loops, I wouldn't have to change the name of the data. So automatically, I will tell the function that's in for loops to do this analysis, the same analysis that I have here from line 80 to 90. And look at each of the files that I want and then do this and execute this, right? So I can tell it to like, okay, look at files with this extension and execute this for me. So I don't have to change the file name. So it's going to be doing the same thing over and over again for the different files. I can tell it, look at a file that has this name on it. Read it, determine the average the information, plot the average the information, and so on. So that is what we'll be using for loops. So basically like a repetition of something without me having to retype everything over and over again. I just tell it to make one command like, okay, if you see a file with this name, with part of this in its name, then do this for me. So that is what for loops do. So basically we are looping over the same command for a different files. Right, so looping over the same command for the different files, right? So before we apply it to our data, we'll try to illustrate this using a normal example so that you actually have an idea what for loops does, right? So imagine we have some words, right? So for loops also does use functions because we are having this command and we're having this files and wanted to be analyzed in multiple times or have this the text that's be analyzed multiple times. So you definitely need to have a function. So a function is just the basis of for loops. So let's assume now we have words and I want to print each word in a sentence. So I have this word, right? And it's in a function form. So the words that I have now, so I'm just gonna create a list of some words that I have. So let's say I love coding. So don't forget our quotation marks. So this is string, so that is why you need the quotation marks. If it has numbers, then you wouldn't need them. So I have this words, and it's just this I love coding, right? So I can call them I can print out the first entry, the second entry, last entry. I can print them in reverse as I've shown you yesterday, right? I can print them however that I want them. But now I want to create a function that's gonna print out the words for me instead of me having to say. So I'm trying to avoid this. Words. So I'm trying to avoid this. I'm trying to avoid telling this to print one. If it's not found, I didn't run line number 99. Let me run it and then run 900. So I'm trying to avoid this, having to print with print one and then print two or print one until three. Yeah, I'm trying to avoid having to specify like print this number, print that, right? So I want to create a function that so that when I specify to it what I want to print and how much of it of that I want to print, let's say I just want to print everything, I will tell it to print everything without, there's a shorter way of actually doing this for me to print everything, right? And let's say now I want to do something different. I want to print this word or that word. I don't want to constantly be busy writing words, print this index corresponding to that string, right? So I'm gonna define a function for that. So you can call it anything that you want as long as you're gonna not confuse it with any other function. So let's say it's print words. And then again, this, how I usually do it, just say this, then put later, and then I want to return something. So this is how I usually start when I print my function. And then I ask myself questions. What do I want to put as an argument in my function? Like, what do I want, right? And what do I want to get as the output for that, right? So what I want is to be able to print each word from this, right? And what I want to return is the words that I wanted to print. So let's say this sentence, if I have a sentence, so if I have a sentence like this, of course, without the columns and the quotation marks, this is a sentence, right? So if I have a sentence like this, I wanted to print certain words. So I wanted to print the first one. And remember that I said if you want to print the words, then you have to explicitly say it. Remember in line 100, we didn't have to explicitly say print, but in a function you have to explicitly say it. So I'm gonna say print. And then when you see the sentence, print the first entry. So whatever sentence that I have, I wanted to print the first entry, right? And if I have multiple words in a sentence, I can ask it to print as many words as I want. So in this case, I only have 3 words. So I wanted to do this for me. So instead of me having to each and every time say print 1, print words 1, words 2, words 3, I'm gonna put a sentence and it's automatically gonna print this for me. So the difference between 99, let me do this, so that you can explicitly see the difference into print there. So the difference between 99 to 102 and 104 to 109 is that this automatically, whenever I have a sentence, automatically prints it for me. But from 99 to 102, if I have a sentence, if I change this, I write it to something else, I'm gonna have to run these lines individually, right? They're not automatically gonna update, unfortunately. But if I have a function, automatically they're going to update, right? So this is what I have. So again, since this is what I'm printing, automatically that is what I'm gonna get. So I don't need this return function there, right? So this is what I'm automatically gonna get, right? So now, let's call my print function, print with, and let's put this sentence into the print function. So already it's gonna print for me, I love coding, right? So I don't have to run each line all by itself, automatically gives me that. And if I change the sentence, automatically it's gonna give me all those things. So that is how one of the ways the function would work. So I don't have to update this, automatically updates depending on which sentence I have, right? So you can also play around with this and use your own sentence and see how what it prints. But of course, since this one is limited to 3 entries, if you have a longer sentence with more than 3 words, then it's not going to print the rest of the words. You're going to have to tell a function to print the other words. So this one is just limited to 3 words, right? Even though this is fine, it's a bit problematic in a sense that if you have a lot of data, you don't print all the elements as I told you. So if you have a longer sentence, you won't print everything. Same thing, if you have a lot of data, it won't print everything in the data, right? So let's do this now. Instead of words 3, let's put a negative and see what happens. So if I say words and then I put a negative there, what happens is that it subtracts the last entry, it removes it, so it only prints I love. Right, I hope everybody gets the same thing. And now let's do the same thing when we're using the function. So words minus 3. Right, see what happens. So I did the same thing. I said words minus 3, it removes the last part, but when I use the function and I say words minus 3, it gives me I love and then NA, right? The reason why it's printing NA is because I'm saying print the words, but remove the last entry. That is what I'm telling it. So it's still gonna print 3, right? However, since I removed the last entry, instead of printing coding, it's just gonna say NA. So instead of just being space, because I already removed the last part, which is coding, it's gonna give me NA. So now imagine you have this data set, right? And you removed a part of it or some point in your data set, and you want to do some analysis on it. So instead of that part that you removed being completely empty, let's say you removed a column or a row, instead of it being completely empty, it's gonna return NA. And for that, it's gonna be a bit hard to do analysis on that data, because now the code is gonna try to do analysis on a row or a column that's written NA. And you don't want that, because that's gonna give you errors, it won't execute, right? So what we want to do now is that if we remove part of the sentence and we print it, we don't want NA, instead we want to have a blank space. Right, so coming back to analysis. So if you remove a column or a row, we don't want the entries of that column. Let me just stick to a column. We don't want the entries of that column to be NA, because we won't be able to do statistical measures or be able to plot your data. You want it to be blank, right? In a sense that that column is removed from your data, right? So that you can be able to do analysis. So that is what we also want to do here. So it means we have to change our function a bit, so that when we print this and we removed some of the sentence, it doesn't return NA. Instead, it returns just makes an empty space. So we can actually do that. So this will be an alternative to this. So this is good, but we can write a better code that executes this, but still gives us what we want. So let's copy this and see how we can change it to return what we want, right? So we have still the same function, we are printing the words, and then we have the same sentence, I love coding, right? But now, let me just write on the same one here. So I'm printing words and have the function sentence. So the argument there is sentence, right? So what we are telling the code is that, so this is where the for part is. So we are going to introduce this, which is called for, and I'll explain this later as we continue with the whole function. So for every word in a sentence. So we're saying for every word in a sentence, again, we're going to need to do parentheses for this one. For, we're going to need to do parentheses. So for every word in a sentence, this is what I want the function to do, is to print. But what is it printing? It's printing that word. So the new function, what I'm telling it to do is that I still have the print words function, right? So I'm telling it that if I have a sentence and I put the sentence in my function, I want that for every word in that sentence, it gets printed. So let's run this. This is 5. You see now how different it is. So this is the one that we had. I think probably learn just to do a comparison. Then we also included in the code, so that you can see the difference between the two functions. Let me take this a bit down. So initially we had the same function, put in a sentence, and then we're printing different entries of the sentence, right? The problem is that when we remove some of the entries, then it gives us an A, and that's not what we want. So an alternative is that we have a similar function, but now we're telling it if there is a word in that sentence, then print that word. So that is why we have 4 in word in sentence. If there is a word in that sentence, then print it. Otherwise, there's going to be space. Right? So if I run this with the first function, you get I love NA because I removed the last part, which is coding. But if I run as an alternative of the first function, it says I love. Because coding now is not part of the sentence, because we are telling it for word in sentence, but now coding is not in that sentence, so it won't print that word. Any questions so far before we go for a quick tea break? Or you can try to absorb that and look at it on your own for those 15 minutes. Well, less than 15 minutes. Okay, let's take, yeah, it's going to be less than 15 minutes. So let's come back at 11:15, and then we're going to do this again. If there are no questions, so let me stop sharing. Or probably I can just leave my screen while it's sharing so that you can see, yeah, so that you can see while you're on the break. Let me try to zoom out so that you can, yeah, if you want to look at this while you're on the break. Yeah, I'll leave this on. So we'll come back at 11:15. Go somewhere on the lines. Everything is fine. Just let me know if you have any confusions. And don't forget to save your files. I'm hoping everybody can follow along. If everybody's fine, then it's fine, we can continue. I'm trying to see if there's nothing in the chat. Seems like there's nothing, so that's fine. We can continue then. So let's say now we have a box plot and we have a strip chart, right? So let's say now you want to add an additional figure that meets certain conditions. So I'm just gonna, let me not edit this one in case you want to look at it. I'll make a different one this side. Right, so now let's say if both of those conditions are not met, or you want to add a different condition to that, you can still do that, right? So let's say if the length of the input is greater than the threshold, right? And another thing that I should have introduced is at the end and the or statements, right? So you can also use that. So if the length of this input is greater than the threshold and you want to use the box plot, so these two symbols, they are referred to end. So let me write them on the side. To end. So these two statements are equivalent to end. So if the length is greater than the threshold, and if you do want to have a box plot, then that's an easy execution, then you're going to get a box plot, right? However, let's say the length is still greater than the threshold, but you don't want the plot to be a box plot. You want it to be something different. You can still do that using the else if statement. And then I'll explain what this does in a few seconds. So the length is still greater than the threshold, but you don't want to use a box plot. And then I'll also write what this exclamation mark means. That's like a negation. This equivalent. Negation. So it's basically the opposite of this. So for line 201, if the length is greater than the threshold and you do want to have a box plot, then it's going to create a box plot. However, if the length is still greater than the threshold, but you do not want to make a box plot, then you can tell it to make an alternative plot. So in this case, let's say you want to make a histogram. Okay, so we have histogram here. You just click on it and then you have your input as X. Right? So now let's say if both statements 201 and 203 they're not met. What else do you want the comments to do? You want it to then have a strip chart. So we still have the else statement there. Let me make it tab so that you can see clearly. So again, to go over through this again, same function, the plotting distribution function. And I have the inputs X, which would be my data. Now a certain threshold of 10, can be any threshold, can be any value. And I'm telling you that if the length of my data set is greater than the threshold, in this case is the length of the columns is greater than the threshold, and I want to produce a box plot for my data, then I can just produce a box plot here represented by line 202. However, if the length of my rows is still greater than the threshold, but I do not want to create a box plot. So the exclamation mark means that is not what we want, right? Instead, it's gonna create a histogram of that. Do you want to say something, Prudence?
Oh, no, sorry.
Okay, sir. So now, if I still don't want this condition same or the conditions are not met, what should happen next? So it means that the length will be greater than the threshold, then it's just gonna create a strip chart. So let's try to use that in our data sets. Calling the same function, plot distribution, right? And we can use the same data that we used earlier on. And then we run this. So now what it has created, and we put this here. So now what it has created, it created a strip chart, which is what we've already established in our earlier code. So if we run the second set of data here, and then we run that, it also it doesn't really create anything so far, right? So remember now, we also have this quotient. So we also have to include that when we are plotting this distribution. Because now so what we are having now is the strip chart. It doesn't show us the box plot, but we've established that the length of this is 60. Oh, this is still 5, so we're still putting the same thing. Let me do for this one. It's complaining. Oh, okay, yeah, now I see why it's doing that. let's go back here. Let's say 11. Right? Do I keep on typing the same thing? Yeah, this should be fine now. So this is the error that I get. Right, the error in invalid Y type in X and Y. So now, since I also have this condition here, I have to tell it whether I want it to make a box plot or not make a box plot. Because we already know that the threshold for this, the length for this is greater than 10. So if you run this in here, you should get 11 arguments cards. I have to use the whole. Yeah. So this is 11 and 11 is greater than 10, right? So we are supposed to either get a box plot or histogram. So we need to include additional arguments to tell it whether we want to have a box plot or we don't want to have a box plot, because it's supposed to give us a box plot if you want it or not a box plot, depending on which condition you want. Because both of this, they're telling us that if the threshold is greater, if the length is greater than the threshold, it's either we're going to get a box plot or a histogram, right? So let's, so it means that we have to include more onto this, right? So we have this data, and then let's say use box plot. Box plot, and then we want to set it to be true. And the reason why setting it to be true is that we want to create a box plot. Unused argument. So let me run this again. Please let me know if you're also getting the same thing as I do from my side. Are you also getting the same thing? If you're trying to do this. That's a unused argument. Please let
Can
me
you
know if you're
scroll
all.
up? Can you scroll up a little bit to the function? I just want to have a look at the
Oh, sorry.
because
Yeah, I
yeah,
didn't
the
include
function doesn't have an
in my
argument.
I just copied the old function. Box plot. Okay, I shouldn't use this, so I'm just gonna rename it because it's a function in here. I'll just set it to true so that you can just use it. And I need to close the bracket. Thanks for that, Amy. And that should be fine. Yeah. So we are looking at line 212. So now we know that the length is actually greater than the threshold. So the length is 11, which is greater than 10, right? And I wanted to use the box plot. That means that it's gonna give me a box plot, which is what we have here. right? So let's see what happens if I set this to be false. If I set this to be false, it gives me a histogram. So which is what I have here. And now if the length is less than the threshold, then it's gonna give me a strip chart. This is less than the threshold, it's gonna give me a strip chart. So we were able to use all those conditions. So now let's say I remove this. Let's see what happens. I still get the strip chart, but if I increase the length, but without specifying whether I want to use the box or not, I get a box plot. The reason why I'm getting that is because I set it to be true, right? So if I don't really specify if I don't want to use it, then it's gonna take this part to be true. But if I remove that and run this line again, it tells me that use box plot is missing with no default value. However, if I still doesn't have a default value, but I specify it here when I plot the function, and then I say true, then it becomes fine. Then if I say it's false, then it's also gonna give you a histogram. So you can either predefine it if needed, or you can just leave it like that depending on what you are working with. So any questions so far? Or comments, or maybe want me to go to a specific line? I know it's a lot to take in. And remember here, we're just using the data that we already have. So instead of this, because we are only using scatter plots, instead of the scatter plots, you can make a histogram. You can make a box plot, you can make a strip chart. So not really specifically supposed to use a histogram, scatter plot. So you can use anything. Questions so far or comments? Let me do this so that I can see what's happening with everyone. Okay, I see there's nothing in the chats. So how did everyone find this section of the workshop so far for R specifically? How did you find it? Will you find it to be easy, hard, challenging, or still trying to digest everything? In personal, I feel like this what you essentially need, especially like if you're doing data analysis. Everything else you can like build on this. Because we've already covered a lot. So just to do a quick recap from yesterday until today. We learned how to load data in R. Right, and I mean, you can see some of the similarities between R and Python, if not very difficult, but it needs practice. It does produce, it needs practice. And you can see the similarities between R and Python. If you've used Python before, even if you haven't done coding before, you can still be able to do this. Just need time. Learn how to load data, right? How to determine what kind of data you have, and how to read certain the columns and the rows of your data, extract information from your data, and do statistics. Is it possible to calculate the p-value? Yes. So the p-value, the chi-squared, it is. You just need to find the code that actually allows you to do that. But it is possible. And we did statistics on it. And we made plots. and we introduce variables, and then we use some functions, inbuilt functions, like the apply one, which makes it easy to do some stuff with it once you read what the function actually does. And we made some plots and how you can change the plots depending on what you want, and how you can change your X labels, the colors, you know, and the symbols that are used in the plots. And what else? And then for today, we learned a lot about functions, how to create functions, pleasure prudence. We learned, yeah, probably people can check out the link that Amy sent on the chats, yes. So today we learned how to create functions, how to call functions, and how to compose functions. Right, and how to input multiple arguments in a function, so that you're not only restricted to one. And what else? How to use for loops, and how to use the if else statements, and how to use for loops within a function. And what else? And how to use the for loops like when dealing with multiple data files, so I don't have to do the same thing over and over again. And I feel like the highlight for programming with R was this portion, for me personally at least, that we're able to analyze each and every file using these lines of code, like this few lines of code. That was the highlight for me. And how to list files using the pattern observed in it. And how to call a function within another function. And how to impose conditions which are the if and else statements. So I probably can go a further step and use this within a function, within this function, the analyze all function, so that to see if they meet the conditions to create histogram, box plot, or strip chart. So I think that's all for me.
Yeah.
So
Yeah.
thank you
Maybe
guys for being.
Can I, sorry, Democrats,
Yeah,
to
sure,
interrupt
you
you.
can
I
say
just
something.
wanted to add, I just wanted to add one thing on what you said. You mentioned about like, if you've seen Python before and stuff. And I just wanted to add that I think that's a really good point, because if you, like, let's say you're learning programming for the first time in R, like these skills translate really well, to other languages. Like even though the syntax or the way that you write things is not exactly the same, like the logic of the functions and the for loops, and that's all very, very useful, useful knowledge. So yeah, just to relate that also to the students.
Yeah, definitely. Thank you so much for that, Amy. And Kisawaka says great sessions, made it easy for a first time user. Yeah, thank you so much. So yeah, we're trying to do this so that you can continue from here. So basically laying a foundation, as Amy did with Python and Git, and as I also did with Root. So this is just foundation, and then you can continue from that in your own respective fields. But you can also feel free to like email us if you need assistance in what we've presented already. So thank you so much. Amy, do you have something else to say? I'm not sure if Tutukila is in here.
Yeah, I don't see Alawani, sorry, go ahead.
Yeah, I see Alwani is here. If you want to say something, Alwani.
Yes. Yeah, thank you everyone for the success of this workshop. Thanks to all the participants, and especially thanks to you, Amy and DJ, for taking your time and taking the participants step by step from shell to programming with R. Thank you very much for that.